Of this work that I present here is already published last year with the team of Professor Vilas Boas and also, of course, Soraya Falcão, which is here. So if you have more doubts or more questions considering this, please go and see this food science paper that we already published. Mistakes in the evaluation of the results. And we see that it was promising considering normally it's the phenolic compounds that can be involved in these anti-inflammatories. So we continue considering these promising results. So if we had the anti-inflammatory activity, we need to see if the cytotoxicity, and we test in two types of cells, lung cancer cells, this CALU3, but also the normal colon cell lines, these FHC cells, where we had no cytotoxicity, and we can see this, for example, for this CALU, if we increase the concentration of the honey, we can have some low in viability of the cells. So even if it's the weakest effect that was observed in B, we wanted to work in, we choose this colon normal cell lines, the FHC, because even in high concentration of honey, we didn't have the lowering viability of the cells. So we still have a good viability of all the cells, and so we continue this in vitro cells so we choose here the FHC. So we test also the anti-inflammatory effect, and we did with LPS, which is a chemical that creates an inflammation in this case in vitro. So we choose the cells of FHC, because when we did it in the CALU3, so the lung ones, we see that what we want is to test the LPS that cause a damage to the cells, and we see here in not only in the cytokines but also the gene and protein level, IL-6 and IL-1 beta, and we see also the LPS and then LPS with the samples of the honey. And we test, of course, the honey isolated, but what we want is to see a kind of protection when we damage the cells with LPS, and when we put the LPS with the honey samples, we see that the damage is not so, it's not the same comparing with the LPS alone. So we see that we have a kind of protection of anti-inflammatory, or a potential anti-inflammatory, because this was our first results for this. And we have this for type of cell A, but also in D and E, which is the commercial one. So, but this was nice results for the A sample. This was for the CALU. So, but the CALU, we see that in the previous results that it has also, if we have higher concentration in honey, we can have a slight cytotoxicity. So it's more safe for us to work with the FHC in the normal colon cells. And once again, the sample A, D, and E showed a better protection of the anti-inflammatory effect when we use it in combination with the LPS that causes the inflammation, and we have interesting results once again for the sample A, D, and the commercial one, E. When we treat the cells, we want to know the protein and the gene values, as I showed you before, but these are cells, so we want to see and to have sure that the morphological changes on the cells, when we have the cell morphology, the normal one, without addition of any samples, that these changes are not relevant. So the cells maintain the confluence and maintain the normal morphology of the cells when treated. With no treatment here, we can see that they have morphological appearance of the cells when we have the honey that I showed you before, even in 1% or 5%, so of the honey A, the D, and the honey E, which is the commercial one. So the conclusions of the sample E, which is the commercial one, and also all the samples, is that the physicochemical, the quality parameters of all the samples that are implied with the color, moisture, conductivity, pH, and also acidity are okay. Let's see. They have the quality and physicochemical parameters considering the codex that are okay. And also we test in this first paper the biological activity for antioxidant, the antimicrobial. We didn't publish yet, but as I told you, we are going to show in this next paper that we are receiving some examples, and one of the promising results in this second paper is the antimicrobial activity.